In this video, I'm going to teach you some visual debugging methods and a tip for making debugging more informative and quicker. Visual debugging is useful in situations where we have data that is more easily represented in visual form. For example, drawing a line to indicate the heading of an object is a bit easier to understand than reading the rotation and position value of that object. I'll also teach you about overriding the toString method to allow us to more quickly debug code and make debugging outputs more human readable. First, let's look at some of the visual debugging. All of the visual debugging in Unity is done through gizmos, and we can see some of those here. For example, moving this object around, we have a line and a target. You can see the traveler left as the object we're moving. Gizmos are very useful for visual debugging. However, they are only in the debugger, and it's only when the gizmos button is checked. They are most useful in situations like movement, rotations, collisions, or algorithms like pathfinding. Anything where it's easier to see the data visually instead of trying to imagine the numbers. We have various options for drawing gizmos. For example, drawing lines, spheres, cubes, or rays. The two spheres I have in this scene are proximity detectors. They have an activation radius and a forget radius. When an object enters their activation radius, they will target it. When that object leaves their forget radius, they will untarget it. Having gizmos allows us to more easily see those radii. Here we're drawing the activation radius in red and the forget radius in yellow. So we've entered the activation radius, so we are targeted as seen by the green line. And when we leave the forget radius, we're no longer targeted. Let's take a look at the code behind that. All of the drawing for gizmos is done in the onDrawGizmos method. And in the proximity center method, we're going to check to see if we have any objects currently in range. If we do, we're going to draw our activation radius in red. We're going to see if we have any targeted items. If we do, we're going to draw our forget radius in yellow. And for each object we have targeted, we're going to draw a line from our position to the target position. Make sure whenever you're changing the color of the gizmos that you always change it back to something neutral. This way we don't change the color of anything that we're drawing after this accidentally. In the update method of this script, we're going to get our nearby colliders by using a physics overlap sphere. This will return a list of all the colliders that intersect the activation radius sphere. If we find any items in this list, we're going to set our currently in range to true. And then for each collider, we're going to add it to our targeted list. Otherwise, we're going to say we don't have anything in range. For each item we have targeted, we're going to check to make sure that it hasn't left the targeted area. If it has, we're going to remove it. And let's take a look at the move towards click script. Here we're going to be reusing some of the things that we've been using in previous videos, getting the input for the mouse and moving the object towards the mouse position. Finally, we've added a onDrawGizmos, where if we have a target set, we're going to draw a line from ourselves to the target and draw a sphere at the target, indicating our stopping accuracy. The stopping accuracy is set because we don't want to overshoot our target. We can see here if we set our stopping accuracy to something very low, we can easily oscillate back and forth because we'll actually move past the target and then move back and forth forever. This is why we want a stopping accuracy that's somewhat higher. Finally, another way to more visually and easily debug things is to override the toString method. So let's look at what we return when we don't have this. I'm going to attach the debugger and set a breakpoint inside our move towards target. Now when we use toString, all we see is the name of the object and the name of the script. However, let's look at our overridden method. See how much more informative that is. Attach the debugger, play the scene. Now when we call toString, we're going to get the name of the script, the target it's heading at, and the speed it's heading there. In this video, I've taught you how to use visual debugging tools within Unity to help visualize the behaviors you're coding. These tools are very valuable for debugging issues that involve movement, rotation, and physics. Using visual debugging often means we don't have to break the code execution, meaning faster debugging. Additionally, I taught you a little trick about overriding the toString method, either on your own custom objects or on the mono behavior itself. This allows you to create a custom debug view for objects for a quick overview of the object's state without needing to employ any more complicated debugging tools.